Guys, can you do question one, please? Question one, guys. You need the election notes to do these questions, guys. Do you have the notes with you guys? Yeah. Alright, good. Are you out as well?
Remind me of
Came off the house roof.
You've got the election notes, right?
Not ours.
So use the,
Two goes down.
the notes to do all four questions. So you need the notes for all four.
Were you happy with your
Well excited. Yeah.
Were you think good about it?
But I mean, other people there's one question which is like a war analogy. It's like we were taking we were doing dot season, but to each value has three quantities, where each quantity is 15 digits long. So they can take the dot you can do, yeah. It's good. Try it. I missed these last two stats.
All right, guys. Let me show you. Can you read this? Oh, I think this is too bright. Let me
Didn't even get it. Just go through it. So it was just it's bold. It's like just the moment where I look at him and I know he is too much to do if I find looking at me. And I'm like, I don't know. So I did it. Yeah,
All right, guys. Let me show you how to do the first question. Question 1, sheet 9. The question is to find the power function. Remember, the notation for a power function is capital Pi, and in brackets you need the parameter. In this case, the parameter is theta, right? So this is, by definition, is the probability of rejecting by definition is the probability of rejecting the null hypothesis given theta. Now for the hypothesis that you are given, guys, are you listening to me? The hypothesis that you are given is theta equal to theta 0 versus theta less than theta 0. Now what's the rule for rejecting null hypothesis in that case? It's in the notes, guys. What does it say? Read it for me. Read the notes. I don't have it with me. I'm lost as well as you guys. Can you read the notes for me, guys? What is the rule when you have theta equal to theta 0 versus theta less than theta 0? What is the rule for rejecting the null hypothesis? It says in the note somewhere. And complete. So, do you have it here? Is it the right one? Yeah. Sorry, number 3. Yeah. Okay. Minus. Yeah. All right. Thank you. Thank you. Do you guys see this from the notes? I just saw it from the notes, guys. So I don't know. I mean, my memory is not as good as yours, guys. So that's why I have to check my notes. Right now, you see, we are conditioning on the fact that the true population mean theta represents the true population mean, and theta 0 is no longer the true population mean because we are conditioning on theta being the true population mean. So what's the first thing you must do, guys? Is the first thing you must do. I've done this enough time. You should know by. The first thing you must do is to replace theta 0 by theta, which is what I have done here. So because of that, I need to add a theta and keep the theta 0. Okay, now I'm going to group these two and take this to the right hand side, right? And if you do that, you will get the probability yeah, this is what you will get. Now if you look at this, guys, I mean, you should know from week 1. This is stuff I mean, you should go back to week 1 or week 2. The stuff we did in week 1 or 2. You will see that this is one of the results that we talked about. Yeah. So therefore, this guy here must have the standard normal distribution, right? Right. Now we can drop the conditioning, guys, because we have used the conditioning to argue that this has the standard normal distribution, and therefore we have used the conditioning. So the condition is no longer needed, right? Right. So this becomes phi is the CDF of the standard normal at okay. So that's question 1. Question 2 is similar. So this is, I'm sure, I mean, this is pretty routine, and we have done this several times already, guys. Is this clear to all of you or no? Your answer? You have a question or what?
At line 3,
Yeah.
it is supposed when you continue at line 4, it is supposed theta minus theta naught. Why is x bar at line 4?
Where's the X?
Yeah. Sorry, man. You mean, yeah, over here, right? It should be theta minus theta 0, yeah. Is that what you said? Yeah. Yeah, thank you for pointing that out. Thank you. Is that right now? Yeah, okay, thank you. I'm so stupid of me. I mean, is that okay, guys, now? And question 2 is very similar, so very similar to question 1. And you do question 2 by yourself, because it's very similar to this. You shouldn't have any problems doing it.
Oh, back door. Holy no way. I have something really disturbing. There's a relief so it was him. The little big piece of roll around these things. But I'm really can't. No, it's a little bit.
Alright, yeah, so so question 2 is very similar. I mean, there's no point. Let me do this quickly and move on. Question 2, sheet 9. So you have pi of theta. So the only difference is just the sign of inequality. So the sign of inequality will be greater than z alpha given theta. So apart from that, everything else is pretty much the same. So you okay, and then you take group these two and take them to the right hand side, and so this will become okay. Now conditional on theta, this, as I said before, this will have the standard normal distribution. So this will be the probability that n or 1 right, and finally you can write, if you like, it's okay to leave it like this too, but if you want you can write this as 1 minus phi at z alpha oh, what did I write? Oh, it's okay. Yeah, okay. So this is, I think many of you already done this anyway. So this is what you will get, I think. Right? And you do question 3, please, now. Question 3.
You always get a lot of so much. It's just asking for it. Basically, you get a point off the point you get to then it'll be next and then you got big X's, you get real flat. You be next and you get 3 points. And I think I shouldn't be these are the ones on the shoulders. You get 300. All we need to do is replicate our results from the first half and we flash it. We'll have to do some of that.
That rise to rise up to
It's using this for something. She used this for something. This as a standard. You understand why? Can I go?
got 4 points.
Next.
So if you end the 90 absolutely. It's the Arsenal thing.
You're probably right. I don't know.
You do question 3, please, guys.
Well, it was like, you know, she like mentioned like she really
No, I'm happy with it.
I went on to do not very well. I was ready to pick them up, but so I went to pick them up. So I just gave it to them, and it was like a spare of me or like 19 just like beer, like or like a cupcake. And that's the only Why did it not work? But I got an email. It was supposed to be one day. I said like you can order it was busy time, so it didn't really. And I got an email with Jack. I was like,
You guys done question 3, guys?
yeah.
Oh, you said you're on.
Yeah,
Oh yeah. All right. Question 3 is on proportions, guys. It's on proportions of. I know some of you are confused about. I know some people are confused about the rejection rules I gave for proportions. I will answer that question in the lecture today from 4 to 5. But let's use the rules I've given you in the lecture notes. All right, for this example class. Okay, so this is question 3, sheet 9. Now, so we want to find pi at p because the parameter of interest is p, not theta anymore. So it's the probability of rejecting H0 given the value for p. Now, if you look at the lecture notes, guys, you will see the rule I gave you, right? What is the rule I gave you, guys? Is root of n divided by x bar times 1 minus x bar, like this, times x bar minus p0 less than minus Z alpha given P. Is that right? This is one rule. I mean, this is the rule I gave you in the lecture note. But there are other rules which I will talk about in the lecture today from 4 to 5. All right. Now to simplify this, guys, I'm going to use the same approach as before. That right. First of all, I'm going to replace P0 by P. So this will become P. So I need to add a P and subtract P0. Okay. And then I'm going to group these two and take them to the right hand side. Okay, so, oh, I forgot to put, there should be a square root here. Then this will become given P. All right. Now I'm going to use an approximate result. Remember that this is not an exact test. It's based on an approximation, as explained in the class, right? So this result is based on the approximation that X bar has an approximate normal distribution with parameters P and variance given by this. So I'm gonna use this approximation to simplify, to argue that this guy here, that is this one here, has an approximate standard normal distribution. Right? If this is true, right? I mean, although this is never true, this is only an approximation, right? Given this approximation, this will have an approximate standard normal distribution, right? So the next one is an approximation of the probability that NO1 is less than minus Z alpha minus okay. So this is what you get. Now remember, the conditioning on P has disappeared because the conditioning here over here has been used to argue that this one has a standard normal distribution, right? Finally, this one will be phi or phi at minus Z alpha minus all right. So that completes question 3. Now, can you get, if this is clear, can you do question 4, please? Which is very similar.
You already know the question for me. When you won't listen.
Yeah.
You get your marks back from reading out.
How'd she do it? But
Let's do 4, please. Question 4.
I wouldn't say it's hard. It's definitely not a lot. I'd say if you like very easy to catch up on, it's not interesting, not a lot of negatives. It's more interesting to get the concept as well. Algebra instructions.
Score, isn't it?
It's just a lot. It's the same
Because there's some of the schools well, it is, but that's X bar is Sunderland. So it's very to the
It's not very hard.
yeah, and so you take the end side of X and cover N squared to get N cube. Or P1 like P over N. You know what I mean?
You need 4 for this semester.
Just take it as get.
Just take
You guys done question 4, guys? Hello? You all done question 4? Yes? Easy, right?
So alright guys, I know question 4 is really trivial. I mean it's the same as question 3. The only difference is the sign. So it's just this is the probability that this is the probability of this happening given the value for p. The next thing is to change p0 to p. Right, the next thing is to change is to take these two guys to the right hand side, so you will get and using the approximation assumption, right? Using the assumption, which is an approximation, we can argue that this is a standard normal. So approximately this will be the probability that n01 variable is greater than okay. And finally, if you like, you can write this as 1 minus phi at z alpha minus all right, so this is the answer. Now the reason I have finished early, the reason I've done this question so fast is because you may remember last week, are you guys okay with this? You may remember last week that we did not finish the example sheet last week. Do you guys remember the sheet last week, this one? This was sheet 5. We didn't complete sheet 5 last week, right? So what I'm going to do now in the remaining 5 or 10 minutes, I'm going to do the 2 questions that I did not do last week. Do you have copies of this? Yes? Do you have copies of sheet 5, which is, I'll put it here if you can see it. This is sheet 5. We did not do question 5 and question 6 last week, right? So what I'm going to do now, I'm going to do these 2 questions in this time I have left. So are you guys okay with this or not? Any questions on this, guys? I mean, this is really, it shouldn't be difficult for you guys. It should be pretty straightforward stuff. Yeah? All right, now let me start with question 5, sheet 5. If you remember the question, guys, last week, the question was that you have this hypothesis that mu is equal to 100 versus mu less than 100, and we want to choose the value for n. N is the sample size, so that the probability that we reject the null hypothesis when mu is equal to 95 is at least 0.9. All right, that's what this says. The probability that we reject the null hypothesis when mu is 95 is at least. So this is the same as saying what, guys? When would we reject the null hypothesis? Under this, it's root of n divided by sigma, which is root of 20 times x bar minus 100. Now this is what we did right now, guys. You should remember the less than minus z alpha is 0.05. Do you follow where we got this from, guys? This is just the rejection rule from the lecture notes, right? Now, you must be careful here, because the true population mean, mu, is equal to 95, not 100, right? So what I'm going to do is the following. I'm going to take away 95 and add a 95. You see in a minute why I'm doing this, right? All right, now these two guys, I'm going to take them to the right hand side. We've done this enough times, guys. You should be bored by this now. 95 minus 100 is minus 5. You should take it to the other side. It becomes plus. So it will be minus z.05 plus 5 root of n divided by root of 20. Are you guys with me so far? Yeah? Oh, did I do this right? Is it plus or minus? Because you have minus. It should be plus or minus here.
Plus.
Huh? Plus, yeah. Okay. Yeah, good. Okay, it's plus. Yeah. Thank you. Right now, what can you say about this, guys? This should have, because we are conditioning on mu being equal to 95, this must have the standard normal distribution, right? That less than minus all right, so this is phi or phi okay. Now I'm going to take the inverse function both sides, right? So you should take the inverse both sides. You will get minus greater than you see what I've done, guys. I've taken the inverse of phi both sides, left and right. So this becomes this. So this becomes 5 root of n divided by root of 20 greater than right. So this becomes root of n greater than all right. So finally if you take the square both sides, n will be greater than 20 divided by 25 So this is the final answer. Obviously, you should have a calculator. You can simplify this to a number. Okay. Is it clear, guys? I mean, I know I did not do this question last week, so that's why. Is it clear to all of you? Yeah. Yes. Maybe some of you guys did this last week. I don't know. All right, so this is question 5 and question 6 last week. I think that wasn't. And I take this away. I mean, you will see this in the scanned version later. You don't really need to copy this down. So question 6. This is question 6. You have is it 10 to the power minus 2? I can't read it. I don't need glasses. So Yeah, okay. H1 we have n is 35, alpha is so we want the probability of type 2 error, which is remember guys, the type 2 error is defined as the probability of accepting the null hypothesis when H1 is true, right? So this is the probability that we accept H0 when H1 is true, but here we are told that sigma is actually 2 times 10 to the power minus 2. So it's the probability that we accept H0 when sigma equal to this. Yeah. Right, now if you look at the lecture notes, once again I need your help guys, because I don't have the notes with me. I've given it away. Can you tell me the rule for rejecting the null hypothesis when you have this when you have this versus this? Is it n minus 1 times s squared divided by what's the rest? I can't remember the remaining. Is it less or greater? Can you read it, please? Can someone read it? Greater, is it? Okay, greater. Thank you. All right. This is from the notes, guys. Sigma 0 squared is, in our case, is 10 to the power minus 2. So what you need is n is 30, so it's 34 times s squared divided by 10 to the power minus 2 4 greater than chi squared 34, alpha is 0.05. Sigma is 2 times 10 to the power minus 2. Now this is no longer the true variance. The true variance is the square of this, right? So what I'm going to do now is 34 times, you see, can you tell me why I have multiplied by 4 and divided by 4? Because the true variance, we are conditioning on the fact that the true standard deviation is 2 times 10 to the power minus 2, which means that the true variance is 4 times 10 to the power minus 4. It's the square of this, yeah. So that's what we should have here. We should have the true variance, right? So this becomes, I'm going to finish in a minute, guys, don't worry. I'm going to take the 4 to the right hand side, so it's going to be 1 over 4 times okay. Now you should look at the lecture notes, guys. You will see, you should look at the lecture notes, guys. You will see that this guy here will have what distribution? Yeah, it will have, come on guys, you should look at equation 72 in the lecture notes, right? It says that this must have the chi-square distribution with 34 degree of freedom, or n minus 1, which is 34 in our case, right? So this is, so the answer to the question is, this is the answer. Right? Is that clear, or some of you seem lost, guys? Do you see what I've done, guys? Because we are conditioning on sigma being equal to this this is the true standard deviation, we need to have the true variance in the denominator, right, which is 4 times 10 to the power minus 4. All right? And then we can argue by equation 72 in the lecture notes that this must have the chi-square distribution with n minus 1 degree of freedom. Yeah? Is that clear or not? Yeah. So that's the answer to question 6, sheet 5. All right, guys, I'll see you guys in a minute. Thank you. I'll see you guys in a sec.